Space appears calm from our world, a quiet darkness filled with distant points of light. But beyond what we can see, the universe holds places that are vast, strange, and often difficult to comprehend. The Boötes Void, a vast emptiness. Far beyond our galaxy, at a distance of around 700 million light-years, lies a region known as the Boötes Void. It was identified in 1981 during surveys of distant galaxies. Scientists expected this region to contain thousands of galaxies, as is typical across the universe. Instead, they found something unexpected: almost nothing. The Boötes Void stretches across roughly 330 million light-years. Within this enormous volume of space, only a small number of galaxies, around 60, have been observed. To place this in context, if our own Milky Way galaxy were located within this region, it would find itself in near isolation. No nearby galaxies, no clusters, only vast empty space extending in all directions. The reasons for this emptiness are not fully understood. It is thought that, over billions of years, gravity may have drawn matter into surrounding regions, leaving behind this enormous gap. Even so, its scale remains difficult to fully explain. It is one of the largest known voids in the observable universe, a place where the structure of the cosmos seems to fall away into near silence. The Eridanus Supervoid, a cold patch in the sky. In 2004, astronomers studying the cosmic microwave background, the faint afterglow of the Big Bang, noticed something unusual. A large region of the sky appeared slightly colder than its surroundings. Further investigation revealed a vast, underdense region of space in the same direction. This region is now known as the Eridanus Supervoid. It lies approximately 1.3 billion light-years from Earth and spans nearly 1 billion light-years across. Within it, far fewer galaxies exist than would normally be expected. Its significance is still debated. Some scientists suggest that it may help explain the unusually cold region detected in the cosmic microwave background. Others believe the connection may be coincidental, or that our understanding of such large-scale structures is still incomplete. Whatever the explanation, it remains one of the most unusual regions observed in the universe. A quiet, extended emptiness set against the otherwise structured fabric of the cosmos. The Great Attractor, an unseen influence. There are regions in space that cannot be seen directly, yet their presence is revealed through their influence. One such region is known as the Great Attractor. Astronomers observed that our galaxy, along with thousands of others, is moving toward a specific area of space at remarkable speed, around 600 kilometers per second. And yet, when they look in that direction, the cause is not immediately visible. The region lies approximately 150 to 250 million light-years away, in the direction of the Norma constellation. It appears to contain a large concentration of mass, possibly a collection of galaxy clusters. However, much of it is hidden from direct view by dust and gas within our own galaxy. This makes detailed observation extremely difficult. What is known is that this region exerts a powerful gravitational pull across vast distances, and it may itself be part of an even larger structure known as the Shapley supercluster. The Great Attractor remains one of the most significant examples of how unseen structures can shape the motion of entire galaxies. Black holes, the event horizon. Among the most extreme objects in the universe are black holes. At the boundary of a black hole lies a region known as the event horizon. It is not a physical surface, but a limit in space beyond which escape is no longer possible. Not even light can return once it crosses this boundary. The concept is derived from Einstein's general theory of relativity, which describes how gravity influences space and time. As matter approaches the event horizon, gravitational forces increase dramatically. Objects are stretched and compressed by tidal forces in a process often described as spaghettification. From an external viewpoint, an object appears to slow as it approaches this boundary. From the object's perspective, however, it continues inward without pause. In 2019, the first image of a black hole's shadow was captured by the Event Horizon Telescope, revealing the region surrounding a black hole in the galaxy Messier 87. Even with this achievement, the event horizon remains one of the least understood boundaries in physics. It marks the point where our ability to observe the universe effectively comes to an end. The singularity, at the center. Beyond the event horizon lies the center of a black hole, a region known as the singularity. Here, matter is thought to collapse into an extremely small point of infinite density. At this point, the known laws of physics no longer provide meaningful descriptions of reality. Space and time, as we understand them, cease to function in any familiar way. The singularity cannot be observed, and no information can escape from it. For this reason, it remains one of the most profound unanswered questions in modern physics. It represents a boundary not just in space, but in knowledge itself. Sagittarius A, the center of our galaxy. At the heart of the Milky Way lies a supermassive black hole known as Sagittarius A. It is located approximately 26,000 light-years from Earth. Its mass is estimated at around 4 million times that of the Sun. For decades, astronomers inferred its existence by observing the motion of nearby stars. In 2022, an image of its shadow was released by the Event Horizon Telescope, confirming its presence directly. Despite its immense mass, Sagittarius A is relatively quiet compared to similar objects in other galaxies. Nevertheless, its gravitational influence shapes the central region of the Milky Way. It governs the motion of stars and gas in its vicinity, maintaining the structure of the galactic core. Quasars, distant and powerful cores. Quasars are among the most luminous objects in the universe. They are powered by supermassive black holes at the centers of distant galaxies. As matter falls toward these black holes, it forms an accretion disk that heats to extreme temperatures, releasing enormous amounts of energy. Some quasars emit more light than entire galaxies combined. They can be observed across billions of light-years of space. However, their brightness is the result of violent and extreme processes. If a quasar were located closer to our galaxy, its radiation would significantly affect nearby planetary systems. Most quasars are found in the early universe, when galaxies were more active and interactions were more frequent. Magnetars, dead stars with extreme fields. Magnetars are a type of neutron star formed after the collapse of a massive star. What distinguishes them is their extraordinarily strong magnetic field. It is billions of times stronger than any magnetic field found on Earth. These fields are so intense that they can disturb atomic structure at a distance. Occasionally, magnetars release powerful bursts of gamma rays and X-rays. These events can release in seconds more energy than our Sun produces in thousands of years. Although they are rare and distant, their nature remains an active area of study. The edge of the observable universe. The observable universe represents the limit of what we can see from Earth. It is not defined by a physical boundary, but by the distance light has had time to travel since the beginning of the universe. This distance is approximately 46.5 billion light-years in every direction. Beyond this limit lies a region we cannot observe. Not because it doesn't exist, but because its light has not yet reached us. As the universe continues to expand, some galaxies will eventually move beyond this observable boundary. Over vast timescales, the night sky will appear increasingly empty. The universe presents a wide range of environments. Some are filled with galaxies, stars, and structure. Others are vast and nearly empty. And some contain objects that stretch the limits of physics itself. Even with modern observation, much of the universe remains beyond full understanding. And in many ways, it is this uncertainty that continues to define our exploration of the cosmos.